All right, everyone, here's our 9.7 notes. We're going to talk about laws of sines and cosines today. And the big thing, I'm not going to really write down a definition, but laws and cosines, I want you to know is that we can use with any type of triangle. Does not have to be a right triangle. So everything we've done to this point has been about right triangles. Now we can have some stuff that works with any type of triangle if it's obtuse, okay, or or like an acute triangle. Now, before we get into laws of sines and cosines, we have a new area of a triangle formula. So, area of a triangle, here's what we have. It's still 1/2. It's sort of like a base and a height, but we have the 1/2. And there's three versions we have here depending on the sides. But here's what it's saying. If I focus on, let's say, angle A here, I can find the area of this triangle if I take 1/2, two sides multiplied together, times the sine of the included angle. Okay, so side times the sine of the included angle, and we still have that 1/2. So that is our area formula, and we'll practice that here in just a hot moment. Next, now we have our laws of sines, and you can write this with your sine function in the numerator or the denominator. As you can see here, it doesn't matter. Let me explain what this is. Laws of sines, you would use this, I'm going to pick a little note here, you would use to find a missing side or angle when you have an angle and its opposite side given. So if you have an angle and its opposite side, and they're both given to you as values, you can find another missing side or angle. And the formula for law of sines says the sine of any angle compared to its side, so that ratio, is going to be equal to the ratio of the sine of another angle in that triangle when you compare it to its opposite side. So that is your law of sines. Law of cosines, a lot of crazy formulas here. They're showing you any of the three options. What you're going to notice is you are going to be solving for either a angle or a side. And you'll notice on the left side is going to be a side. And on the very far right side, you will notice that I'm going to have the angle that's opposite that side. So whatever you're looking for, if you're looking for the missing angle or the missing side, you are going to find that missing angle or side you're looking for, and you're going to use a version of the formula that either has that missing side all by itself being squared, or that missing angle over here for your cosine. And so whichever one you use, you have to have its opposite side or angle in that same formula. The other two sides in the triangle are going to be what's here in the middle. And we're going to see that to play here when we go to the next page. I'm going to skip questions 1 through 3. It's just you typing these in the calculator. Just make sure you're aware that if you take the sine, cosine, or tangent of an obtuse angle, you're going to get a negative number. It's just, you're still going to get one just because obtuse. Our ratio is going to be slightly weird looking. Not a big deal for us in this class. So skip. Let's look at number 4 and 5. They want us to find the area of the triangle. Again, the area of the triangle is 1/2 times the two sides that I have. So I'm going to put 14 times 9 times the sine of the included angle, which is 79 degrees. I'm going to type all that in the calculator, and I'm going to round to one decimal place, and that's, I believe, 61.8. And after me just checking that, that is correct. Okay, for the next one, let's go ahead and do the same thing. Area equals 1/2 times the two sides, so 19 and 22, times the sine of the included angle, which is 24 degrees. Put that in the calculator, round to one decimal place, it just so happens to be 85. Now, of course, these would be units squared because we're talking about area. Really simple formula to use. Now, let's go ahead and look at question number 6. Now, it does say solve for the triangle. I'm not sure if I'll do all of the parts of the triangle for number 6. Actually, let's go ahead and do that. So for number 6, I need to know the measure of angle A, angle B, oops, if I can draw an angle sign, and then angle C, and then I gotta find little a, little b, and little c. I'm gonna fill in what I know. I know angle A is worth 50 degrees, angle B is worth 30 degrees, little a, which is across from big A, I don't know. Little b, which is across from angle B, is 22, and C, I don't know. All right, so based on what I see there, I already noticed that I have two of my three angles. So if I have two of my three angles of a triangle, all I have to do is do my triangle sum theorem to find my missing angle. So in this case, my missing angle is going to be 100 degrees. So I can write that 100 here, and that'll be for angle C. So there is my degree measurements for all of my angles. Now, if I only have one known angle, then I'm going to use some trig functions. Now I'm going to highlight something. I see an angle in its opposite side, and I have my other angles. If I have an angle on its opposite side, I can use my law of sines. So my law of sines says I can take that ratio and compare it to another ratio. So let's say I want to find side A. Side A is compared to the sine of 50 degrees. And I can set that equal to, now since my sine's in the bottom, I have to put my bottom be the sine, my denominator be the sine of now 30 degrees, but the side that it's attached to is 22. To solve for this, all I have to do is multiply both sides by the sine of 50 degrees. So I'm going to put this whole thing in the calculator, and I'm going to get A equals 33.7. I wrote my numbers wrong earlier up here at the top. I realized I put 22 in for A. That was for B. So B is going to be 22. Now my A is 33.7. Now this is not a right triangle, so unfortunately I cannot use Pythagorean theorem to find my third side. But what I can do is set up one more trig function, and I can do the same thing, but for C, C is attached to 100. So I can say C over sine 100 equals 22 over sine 30. I multiply both sides by the sine of 100, and I get C is roughly 43.3 degrees. Not degrees, 43.3. Not degrees. So that would be your law of sines. And now my triangle is solved. Let's go over to 8 because number 7 is almost, yeah, I'm not going to do number 7 right now. I want to go over to number 8 because number 7 I can use law of sines. Number 8 I cannot use law of sines. So I'm going to make angle A, angle B, angle C, write down what these are. And then I'm also going to write down, I need little a, little b, little c, so the side lengths. And all I know is that little a is 5, little b is 7, little c is 3. You'll notice I don't know any angles. So let's go ahead and see what we got here. I'm going to look at, let's find angle A. So angle A, is, since I don't know it, I'm going to have to do cosine angle A, which means I need my little a, so my side A to start with, which is 5 squared. And now I put my other two sides, which are B and C, in the middle squared. So I'm going to say 7 squared plus 3 squared. I'm going to do minus 2 times 7 times 3. So I guess I should write what I just did. I just did a squared equals b squared plus c squared minus 2bc times the cosine of a. So what I don't know is that cosine of a. So first off is I'm going to put in 3 squared plus 7 squared in my calculator to get a here. So let me see, 3 squared plus 7 squared is going to give me 58. We get 25 equals 58 minus 2 times 7 times 3 is 42 cosine A. I'm going to subtract the 58 from both sides. So I can write 58, not 88. And I'm going to get 25 minus 58 is I get negative 33 equals negative 42 times the cosine of A. I divide both sides by the negative 42, and I get 0.79 equals cosine A. But I want to find A, so I got to take the inverse. So the inverse cosine of 0.79 is going to equal my A. So the inverse cosine of that answer, rounded to the nearest degree, is 38 degrees. So angle A is 38 degrees. Now I can write that in here. Now the thing with that 38 degrees is now what I can do is I have an angle and its opposite. So now I can switch to law of sines to figure out one more of these. So I'm going to go ahead and do that. I'm going to find angle C now. So I say sine. Where am I at? Here's where I'm at. I'm going to say sine of angle C compared to 3 is equal to the sine of 38 over 5. So I'm going to take sine 38, divide it by 5, and multiply that by C. That gets me to say sine of C equals 0.37. To solve for angle C, we're going to take that inverse. So the inverse sine of 0.37, that means angle C is going to be worth 22 degrees if we round to the nearest degree. And then to find angle B, we can do our triangle sum theorem. So we can take 180 and subtract the 38 and the 22 that we know, and we're going to get angle B is 120 degrees. All right, there's your 9.7 notes. Have a great rest of your day.